Today I'm going to be demoing my dictation software, Speech to Command. It's the first dictation software that allows programmers to code by voice. It's primarily for those with RSI, or repetitive strain injury, which is basically, it's not a disease, but it occurs when you type too much, which is common with programmers, and it makes it very painful to type. At the peak when I made this, I was typing with chopsticks, even like I had stopped going to the gym. Like, it was just very painful, and it's a crippling career it cripples programming careers for sure. Like, if you just Google RSI programmer, this is one of the first ones. It's just a potentially debilitating condition. There's relief surgery, and none of them actually help you continue coding. Most of them just say stop. Get surgery. Even if you navigate to where it says voice activated software, he just explains how there's no dictation software that allows you to write technically as for coding. So when you download the application, it's just a simple zip folder. You unzip it, and you can click on the jar. It's an executable Java file. If you need the Java runtime environment, it should probably be installed already on your computer, and you can execute it by the command line like I usually do, but you can also just click on the executable right here. But I'll just click on it. So this Java executable is the back end of the program, and then this is the front end, which is the feedback console. You can just ignore this; doesn't have anything except when you're quitting it. You just close that. And this is the dictation console, which has dictation modes. You can look at the documentation for what that is on the website. This is the feedback console, the dictation toggle, and the customizable grammar libraries, which you can read about on the documentation for this website. Alright, so I'm going to begin with a demo on coding by voice, and I'll begin with that now. Alright, bye. Alright, so let's get started. I'm going to show that coding by voice is possible by copying this sample Java file onto this blank Java file. Alright, so let's begin. Insert public class semi-speaker semi-braces. Return spacing public space semi-speaker semi-space parenthetical. Semi-string semi-space speaker pause space. Semi-string semi-space words. Normal jump after braces. Normal down below return. Public space void space speak space parenthetical. Semi-string semi-space speech normal jump after braces. Console speech. Normal down below return main. Semi-speaker semi-space Randy space equals space new space semi-speaker semi-parenthetical. Normal jump after semicolon. Normal left delete. 4 teleport. Insert speak parenthetical. Speaker space plus space words. Normal jump after semicolon. Normal left. Left delete delete. In demo, I'm just going to be showing the main feature of the dictation software that makes it customizable, which are these grammar libraries. So if you scroll down on your dictation console, you'll see your grammar libraries listed here. So all these 5 libraries were written by me without code, just as you can do. So right now I'm going to show you how to make a new library and show you what it's used for. First, let me explain what the libraries are. So each grammar library consists of sets of phrases that are mapped to key presses or like key sequences. So this phrase blocker, or any of them, like this, for example, this one blocker, when I say blocker, it'll execute this key sequence, which is just this little short end block comment for Java, or some of them could be longer for tedious typings, such as console. That's just another mistake in recognition for console, like up here. So what it'll do is when it recognizes the word console, it'll print out this sequence of characters of ASCII keys, system out.println, which any Java knows is just like a tedious print statement, and it's a lot easier to automate it with voice. And then this is a special syntax created so you can execute non-ASCII characters called key presses, and you can look at the documentation. Each non-ASCII keyboard key is registered with a constant name. So what this does is it types out this character sequence, and then it executes this non-ASCII key sequences with just press the left key 3 times to enter into the parentheses for convenience for entering what you want to debug. Alright, so now I'm going to show you a demo on how to create your own grammar library and what it's useful for. So let's call this like Java convenience. Although I'm just using Java as an example. You could use any languages, or even not a programming language, but I'm just using Java as an example because it's my favorite language. So Java convenience demo, and we'll make a custom key phrase, I guess, called iterate, and this is just going to be a simple for loop. So I equals 0, I is less than blank, increment I. Okay, so first we're going to see when I execute this. Insert iterate. But you can see that this is useful, but it's not that great because I have to scroll back, which I can, like saying 3 back. Or it's not up. But I'd have to iterate, I have to move back here and do it. So what the key presses are useful for is that we can actually move back into them and like move our cursor to this place. So I've shown that, for example, right here. Let's see, in the console, for example, the syntax is in the documentation you can look up, but it starts with, I'll just explain it. You start with this key press start syntax, and then you enter the key constants delimited by commas without spaces. And it's important that you do without spaces because this would be registered as a new word. So if I wanted to, I could execute the left key press until I got here, and then the cursor would be here. Or if I wanted to be extra convenient, I could like go left, insert a return, and then go up here, and then get my cursor right here. So that's what I would do. So this has just been a demo of the grammars and what you can do with them. All right, thanks.